Now that you've had a chance to see what completing the square is and you've used it to solve a quadratic equation, now we're going to use it to change a quadratic equation that's in standard form to vertex form. So I'm going to leave the same steps here. I am going to tweak step 1 a little bit. So the second example, there's 2 examples. The second example I'm going to do using these steps exactly, and then I'm going to show you another way to do the second example where you use step 1 in a slightly different way and you do some factoring instead of some dividing. So let's start by looking at example 1. So first thing I'm going to do is I'm going to divide all my terms, so my quadratic term does not have a coefficient. But since my quadratic term's coefficient is 1, I can skip that and just subtract the 5 over to get x squared and 2x on the same side, giving me y minus 5 equals x squared plus 2x. Moving on to step 3, I'm going to take my linear term, which is 2, divide it by 2, and I'm going to square that result. That is the amount I'm going to add to each side, giving me y minus 5 plus 1 equals x squared plus 2x plus 1. I now see that this right side is factorable. 2 things that multiply to be 1 and add to be 2 again comes from here. It's going to be 1 and 1, so rather than write it twice, I'm just going to say x plus 1 squared. Over here I end up, when I combine like terms, y minus 4. Taking a last step, so when we're solving, we plug 0 in for y. When I'm changing to vertex form, I want to get y by itself because, again, I want it to be in that. I probably should have wrote this down to begin with. In that form, y equals a times x minus h plus k form. So I'm going to go ahead, as I said, add 4 to both sides, and I get an equation of y equals x plus 1 squared plus 4, and I have to identify my vertex per my directions here. So my vertex is going to be h comma k. So in order to match this equation, I would have had to have subtracted a negative 1 to get plus 1. So I'm going to say my h value is negative 1 and my k value being added on is 4. And like I said, I do have 2 examples. The second one I will do twice. Show you 2 separate ways to do it. So the first way I'm going to do it, I'm going to follow all my steps. So my first step tells me to divide to get my x squared without a coefficient. So I'm going to divide everything by negative 4. So I'm going to have y over negative 4, which is the same thing as saying negative 1/4 y equals x squared minus 2x plus 10 over 4. Then I'm going to get x squared and x by itself, so I'm going to subtract 10 over 4. I know that in reduced form, 10 over 4 is the same thing as 5 over 2, so that's actually what I'm going to subtract. And then moving on to step 3, I'm going to take my linear term, which is negative 2, divide it by 2, square that result. That's what I'll add to both sides, giving me negative 1/4 y minus 5 over 2. I'm going to say, instead of saying plus 1, I'm going to say plus 2 over 2. Just to anticipate that I'm going to have a common denominator in my next step, and add 1 here. This then gives me negative 1/4 y minus 3 over 2 equals x minus 1 squared, since negative 1 times negative 1 factors multiplies to be 1 and adds to be negative 2. Again, it comes from right here. So now I want to get y by itself, so I'm going to add 3 over 2 to get it into that vertex form. And then in vertex form, it is y equals a times x minus h plus k. So I'm going to multiply by negative 4 to undo that. So I'll multiply everything by negative 4. So negative 4 times negative 1/4 is going to leave me with just y equals negative 4 times my first term, x minus 1 squared. Negative 4 times 3 over 2 is going to give me negative 12 over 2. I'm out of room, so I would write this in another step, but since I'm out of room, I'm just going to go ahead and erase that and change that and say 12 over 2 is the same thing as 6. And there's my vertex form. And I can go ahead and say that my vertex is going to be 1 comma negative 6. I could also describe this as a translation and say that my x squared function is moved 1 over to the right and down 6. It's also reflected over the x-axis, and because of the 4 out front, it's also going to vertically stretch it, giving it a skinnier look. But let me show you another way to do this problem. So the other way to do it would be, instead of dividing everything by -4, I'm going to flop step 1 and step 2, and I'm going to start by getting x squared and x by itself, and start by saying I have y plus 10 equals -4x squared plus 8x. And now instead of dividing by -4, I'm going to factor a -4 out of this side, and then I don't have to worry about all those fractions, giving me y plus 10 equals -4 x squared plus 2x. So notice I'm not necessarily factoring out my GCF, just my coefficient. Now my linear term is 2x, so I'm going to do 2 divided by 2 is 1. I square that and I get 1. Notice that that means when I add that to this side, I'm going to add it inside of the parentheses because it's that stuff, the x squared and the 2x in the parentheses, that I want to be able to factor. Well, this -4 would technically distribute to everything in here, including that 1. So while it looks like I added a 1 to this side, the reality is that because the -4 distributes in, I really added a -4 to this side. So to keep my equation balanced, I also have to add a -4 to this side, giving me y plus 6 equals -4. This now factors to be x plus 1 times x plus 1. Ooh, I have a mistake. I'm going to tweak all of my work very quickly. I'm going to do it in a different color. When I take a -4 out of 8x, I should have been left with a -2, which would have made that -1, which would still square to be 1. But this would be minus here, and that's now going to make a difference. So it won't change anything, except now when I factor it, I want it to factor to be x minus 1, not x plus 1. Squared. And my last step to get y by itself to be in that vertex form, I'm going to subtract 6. And this will be my form. So notice I get the same answer regardless of which method I choose. I prefer the second method, but what I've noticed sometimes is students who are just learning the completing the square method, they want to stick with one method rather than try to incorporate this new piece. So go ahead and choose, because either way, you'll get the same thing.